Okay, so I'm recording this meeting and we'll be discussing clustering in Weblogic today. Yesterday we discussed about deployments and we also deployed our sample applications in Weblogic cluster. So let's go ahead and see about clusters and we'll see that. Okay. Right, so cluster in Weblogic. So Weblogic cluster is mainly multiple Weblogic server instances running simultaneously and working together to provide increased scalability and reliability. So what we do in a cluster is we create a number of managed servers, so it should be 2 or more. So when we have those many numbers, we can add those managed servers into a cluster, and those managed server added to cluster can be scalable later, and we also can take requests to each other, so requests can be copied across, and that brings in high availability for those managed servers as well. So using cluster we can attain scalability and high availability. Now this cluster, it appears like a single instance to clients. So some requests coming from the outside, they doesn't go to managed servers directly, and the cluster takes it as a single address, and then internally it distributes it to the managed servers. So to the outside world, to a client, a cluster appears to be a single WebLogic server instance. Okay, so the server instance that constitute a cluster can run on the same machine or may be located on a different machines. So managed server instance, which we cluster, it can be on the one machine or it can be across machines. So if we have machine A, machine B, machine C, we can have managed servers on two managed servers. Let's say, let's take example of two managed servers on machine A, another two on machine B, and another two on machine C. Now we can make a cluster across, so that this one cluster will have server instances from box A, box B, and box C. So there is just one cluster, but internally it refers to 6 managed clusters which are distributed across 3 different boxes. But to clients, still your cluster will be same, so it will look as one WebLogic instance which internally distributes the request to other managed servers. So cluster always looks as a single WebLogic server instance. No, we can also increase the cluster capacity by adding additional server instances to the cluster on existing machine, or you can add machines to cluster to host incremental server instances. So what does it say? So let's say I have a cluster. Let me show if I have a screen. Okay, let's see here. For example, I have administration server. I have this administration server, and then I have created, okay, this is a 2 cluster example. Let's consider just one cluster example. So for example, this is my managed server 1 and this is my managed server 2. I've created a cluster A. Okay, so this is different. Okay, so I should go for a different example. Let me go to Paint maybe. Okay, so let's say this is one machine, this is another machine. Okay, and I have formed a cluster. Okay, so consider this one is my cluster, and this is a machine, first machine, machine A, this is machine B. So if I made a cluster as so I have a machine on cluster, I have made a cluster on this as well. Now tomorrow if organization needs that they buy one more box, and there is a separate box being bought, which is box C. So consider this is box A, box B, and box C. Now I already made a cluster from box A and box B. So let's say there are 2 minutes over here, 2 minutes over here, and I bought another box, another new box being procured, and I have done the installation of Weblogic and created 2 minute servers. Now if I want to make it part of same cluster, that is also possible. So I can extend a cluster even to a new machine. That is being possible. So that's what this line says here. Yeah, so we can increase the cluster capacity by adding additional servers instances. It is also possible, let's say in box A, if we have 2 managed servers, and in box B we have 2 managed servers. Tomorrow if I want to increase the number of servers, I can create 2 additional managed servers on box A, also 2 additional managed servers on box B, and they can still become the part of same cluster. So when I create a cluster, I can always add more number of managed servers to it. Also, I can add a new box being procured. So any additional box coming in, that also can become a part of a cluster. So it's highly scalable that we can design new managed servers as a part of cluster, and also a new infrastructure comes in as a part of procurement, that also can become part of a cluster. So it's highly scalable, and we can extend it for managed servers and for a new box. Now each server instance in a cluster must run on the same version of WebLogic server. So this must be noted, because for a WebLogic cluster, it is required that all the server instance should be of same WebLogic server. So like I gave you example earlier, so there was a guy who tried once to cluster managed servers from a Windows machine and clustering those managed servers with a Linux machine. But the version of WebLogic was different. So he was doing it across 1112C. So if you do that, that fails. So you have to make sure that you are using same version of WebLogic server if you're trying to create a cluster. Now cluster relations to domain. So how does it relate to domain? So it is part of a cluster. So cluster is a resource within a WebLogic domain. So it is always a part of a cluster, because it is created through admin console, which controls your resources. So your admin console, if you are in admin console, you can create a cluster and then assign managed servers or resources to it. Domain, as we know, it is interrelated set of WebLogic server resources that are managed as a unit. And domain includes one or more WebLogic server instances, which is nothing but admin server and managed servers, which can be clustered, non-clustered, or a combination of clustered and non-clustered. So within a domain, when we create managed servers, let's say if we have created 5 managed servers, now we can have a cluster of 4 of those. Let's say server names are A, 1 2 3 4 5. So there are 5 servers. So I can also create multiple clusters. There is a possibility that multiple clusters can be created. So let's say in cluster A, I've created machine 1 and 2. So 1 and 2 is being assigned to cluster A. 2, 3 and 4 is assigned to cluster 2. So I have 2 clusters. Cluster 1, I have assigned 2 machines. Cluster 2, I have assigned 2 machines. Now there is one more machine which is pending. So I'm not clustering it. Instead, I'm keeping it alone. So I can cluster it. I can keep it non-cluster. So machine 5, so managed server 5 will be non-clustered, and 1, 2 and 3, 4 will be cluster 1 and cluster 2. So that's being possible. I can have different configurations depending upon what I want my environment to be done. And a domain can include multiple clusters. So like I told, we can have multiple clusters. I can create 2 clusters within a 5 managed server configuration. With 2 managed servers, I can create cluster 1, another 2, 3 and 4 I can create cluster 2, and I can leave the 5th one separate, so it becomes non-clusters. Now a domain also contains the application component deployed in the domain, and resources and services required by those application components and server instances in the domain. So okay, this any deployments like we saw earlier, any services if required I can deploy. I can deploy it into a cluster. I can deploy it into an individual machine which is non-clustered. So that's been possible. Now, all server instances in a cluster must reside in the same domain. You cannot split a cluster over multiple domains. Okay, so what it says is, let's say I have a single machine and I have created two domains into it. So I've created domain A and domain B. Let me take back to this. So for example, so this is my domain A and this is domain B. So this is, consider this domain now. I think I should use text boxes, so that would be better. Let's say this is my domain A configuration. This is domain B. Can I color it? No. Okay. Okay, so domain A and domain B. Hold on a minute. Now, if I've created a cluster associated only with this one. So this domain A is associated with cluster. Now, same cluster, if I want to assign it to domain B, another domain, that is not possible. So I cannot do this. This cannot be done. So within a domain, if I want to extend it, it is possible. But across domains, if I have two different domains, I cannot make a cluster out of it. So that's not being possible. The reason is being simple. So domain A will have its own set of resources. So there will be one admin server here. Which controls my domain A, and there will be other admin server which controls my domain B, so another domain. So now when I try to create a cluster, so I have a cluster on domain A, and now when I'm trying to use this cluster for another domain, it is not possible. The simple reason being the administration server using which I've created this cluster, so the resources which is controlled by this admin server and this domain, they have information about this cluster. But another domain and another admin server which is being created at this domain, it doesn't have the information about the same cluster. So this cluster addressing will not be available to this domain. Considering that this domain doesn't have information about the cluster created on domain A, this cannot be clustered. So simple reason is this resources, the cluster resource which is being created as a part of domain A will not be available to domain B. Hence we cannot cluster across domains. So that's not being possible. So we cannot split it across domains. Now, okay, so what are the benefits of clustering? If we do a cluster, it provides scalability and high availability. So what is scalable? Scalability is whenever you need, there is an increase in demand or decrease in demand. So I have, let's say I have created a website, a shopping website initially, and I'm considering then in next 3 months, it's gonna get 1,000 user base. So at the moment, probably about 50 users are hitting my website, and my one server can support at least 40 users. Okay, so in that case, at the current scenario, I just need 2 managed servers. So my one managed server can support 40 users, and 2 managed servers can support probably about 80 users. Now at the moment I just have a requirement for 2 managed servers, so I'll create 2 managed servers and those 50 users can easily access my website. Now over a month of time, I saw that more number of users are coming in. So let's say 100 users are coming in, and sometimes that link will not be available. The reason is being simple. So for 50 users, 2 managed servers were enough because one managed service can support 40 users. But when 100 users comes in, for 20 users, I cannot support, my managed servers cannot support that. In that case, I'll have to expand my servers. So I'll have to add one more managed servers, which makes my capacity to 120 users. Now 100 users can easily log in. So similarly, over a quarter, if I see in 3 months time, I am going to get 1000 users. Based on that, I'll have to increase the number of servers. So that can be easily done using a cluster. So we have already formed a cluster with 2 managed servers, and in future more number of managed servers are required to be added to the cluster. Without any interruption to the service, we can do that. So we can create additional managed servers and we can make it part of the cluster. So that can be done. Now in terms of high availability, so high availability is you're already running servers which fails. Let's say I created just 2 managed servers, okay, and my user base is 50, and one managed servers same, it supports 40 users. Now in case one of my managed servers fails, now 50 users, they're accessing just one, they are just accessing just one managed servers, which it cannot support because it can support only 40 users. So either my website processing will be slow, or users will get a timeout, or the page cannot be displayed. So for few users, it doesn't come up properly and it will send some interruptions. In that case, I'll have to make it highly available. So what I can do is I can probably create about 3 managed servers, and I'll make it highly scalable, or in case I can have those managed servers across. So let's say I've created four managed servers, 2 on machine A and another 2 on machine B. Now these 2 managed servers can support up to 100 users. Similarly, on machine B, the 2 managed servers can support up to 100 users. So my total capacity is 200 users, but I still want it to be highly available. So I don't want my users to be dependent on machine A. So let's say if my machine A goes down completely, my website is down and my user cannot access my website anymore. In that case, I'll make a cluster across. So I make a cluster across these machines. So in case one of the machine goes down, another machine can still serve the request. So my website will never be down because it can it still will have the details of that website, and website will be keep on up and running. And in the meantime, I can also fix issues with this managed service. So mainly I have to make it highly available so that anything happens to any instance of managed service fails, any instance of server instances fails, it can still run from the another server. So this is what it says. In a WebLogic server cluster, application processing can continue when a server instance fails. You cluster application components by deploying them on multiple server instances in the cluster. So if a server instance on which a component is running fails, another server instance on which that component is deployed can continue processing. So in case any of the managed servers fails, any other managed servers which is being part of a cluster, it will have the information related to that request, and that request can be processed using another managed service. Okay, so also it provides the capability for application failover and load balancing. So load balancing is done across managed servers. So depending upon the type of load balancing mechanism you use, so there are different algorithms available for load balancing. So what kind of load balancing we are using? Your managed servers can load balance among each other. So a cluster, a request comes from outside, a cluster takes that request, and depending upon, let's say if I have set it weight-based algorithm. Now your WebLogic cluster will see which server is not occupied. So the server which is processing minimum number of requests will be sent to that server. So let's say across 4 servers, if server A is already processing some requests, server B is already processing some requests, then it will be passed on to C or D, depending upon whichever is available before. So that load balancing can be done through a cluster, and it can also do application failover. That means if any particular object fails or anything fails, that information can be available to other managed servers, and that managed servers. So let's say uh, there was a transaction going on, there was a processing. So someone was trying to add a cart, add some product to a cart, and at that time one of your managed servers fails. Immediately it will be picked up by other managed server, and that managed server can take that request and continue from there. So this makes application failover easy. So any of your managed servers fails, requests can be automatically picked up by other managed servers and at the client, and they'll not find any issues complaining about website not available or cart not available. So this application failover can be done through clusters. So if you do a cluster, it provides you application failover facility and load balancing. So these are the capabilities of this. Okay, so what type of objects can be clustered? So we can cluster these objects. You can cluster servlets, you can cluster JSPs, you can cluster EJBs, which is enterprise Java bench. This is Java servlet pages. Servlets, remote method invocation, RMI objects also can be clustered, and Java messaging servers. So the destinations. So these can be clusters. So Weblogic server, it provides clustering support for servlets and JSPs. So it does it through HTTP session replication, this HTTP session state. So this also further can drill down to many. So you can use external load balancer, or you can do it internally through Weblogic. So we'll see that in a later section. But in case you want to cluster it, let's say for HTTP session, if you want to maintain HTTP session state, it can be done in three ways. It can be done in memory, a file system, or a database. So what is in memory? In memory is where the session state is being stored within the memory, and using that it is being processed. So that's in memory. It is being faster, and it is recommended if it is quite small. You're getting low number of requests. A file system is where you store the state in a file. So there is a file system which you have created. So everything is being stored in a file, and using that file system, this session state will be maintained. Or you can also configure a database where you're storing those values into a database, and your information is passed through a database. So that's way. So there are three ways for HTTP session states: in memory, a file system, and a database. So it can store in memory, it can also store in a file, or a database. So that is being possible. Okay, so methods of clustering. What are the methods of clustering? We have this horizontal clustering and vertical clustering. So consider this: horizontal is like everything laying on the same block. So if I'll show you in terms of design, so this is called your horizontal machine, horizontal clustering. So you have just one machine, and your managed servers, you are keeping everything on the same server. Now same thing, I can have three machines, and then I can make cluster out of these three machines. So mainly you are creating one within a machine. You are creating a cluster where it's just one machine, and you are creating more number of managed servers here. So when you create managed servers within the same machine and cluster it, it is called vertical clustering. When you have more number of machines, so I have box A, box B, box C, and when I create a cluster out of them, that is called horizontal clustering. So horizontal clustering is across boxes, and vertical clustering is within the same machine I am trying to create a cluster. So horizontal clustering, it involves running multiple Java application servers, which is nothing but managed servers that are run on two or more separate physical machines. So two or more. So minimum two is required, because a server, physical machine A and physical machine B, where I have created my Java application servers, which are my managed servers. So I've created managed servers, and when I do a cluster of them, that is my horizontal clustering. Vertical clustering, again, it consists of multiple Java application servers on a single physical machine. So I have just one machine, and I've created managed servers on that machine, two or more managed servers, and when I make a cluster of that, that becomes my vertical clustering. So the machine processing power, CPU usage, JVM, heap memory configurations are main factors in deciding how many service instances should be run on one machine. Like we saw earlier, depending upon the memory, the RAM available on your system, you can decide the number of managed servers you can create when you are going for a vertical clustering. That is also applicable for horizontal clustering, but when you go for horizontal clustering, of course you get the more capacity. The reason being, you have more infrastructure in place, you have more number of physical machines, so definitely more number of RAM, more number of CPU that's being there. So depending upon that, you can create more number of managed servers. So remember this, vertical clustering is when you create managed servers on a single physical host or a single physical machine. You create managed servers and you make a cluster only on that machine. That becomes your vertical clustering. And when you have more number of physical machines, two or more physical machines, and you created managed servers on those machines, when you make a cluster out of those machines across these physical machines, that becomes your horizontal cluster. Now, WebLogic server communication in a cluster. Okay, so IP sockets and IP unicast and multicast. Sockets, we don't need to discuss this much because this is what we don't use most often. This is the one. IP unicast and multicast is what we'll see. Although unicast is recommended because it is simplified process and it is more efficient, but if requires, sometimes multicast can also be used depending upon your server configurations or your organization's requirement. Now, what is this IPcast IPcast and unicast? So IPcast IP multicast is a simple broadcast technology that enables multiple applications to subscribe to a given IP address and port number and listens for messages. So when you create a multicast communication, at that time, while creating multicast cluster, we have to specify a IP name and a port. So when we specify that IP and port, all these messages from the servers, they will listen to that particular address and port. So that combinations, it will, all these managed servers, they'll be sending their heartbeats to that particular ports, and using that, all managed servers, they have to get their status. So this IP multicast broadcast messages to applications, but it does not guarantee that message are actually received. So it's like it just sends a signal saying that okay, it broadcasts the message, but it doesn't confirm whether these messages are being received or not. So let's say I have sent you a courier, and then if that courier is being received or not, I am not taking acknowledgement. So it may be missing, and I'll consider that okay, I have sent it to you, so you already received it. So but you may or may not receive it, on that particular day. So this is how multicast works. So it broadcasts message to application, but it does not guarantee that messages are actually received. Now if an application local multicast buffer is full, new multicast messages cannot be written to the buffer, and application is notified when messages are dropped. So this is another drawback of this multicast. So in case the buffer gets full, it cannot write any more messages to it. Because of this limitation, WebLogic server instances allow for the possibility that they may occasionally miss messages that were broadcast over IP multicast. So IP multicast, that is the challenge, although it has a dedicated IP and port, but there are issues with the messages. It broadcasts messages and it doesn't take the confirmation that those messages are being received. And also if there is a buffer full, then new messages cannot be written to the buffer, and then application will not be notified that these messages are being dropped. So server who are part of a cluster, they will not get sync, they will not be aware that some messages is being missed. So there is a limitation that these managed servers which are part of being multicast, they may miss some messages which is broadcasted by multicast addressing. Okay, and then this multicast address, it has a range of IP. So if you are using a multicast, you can specify a IP between this value. So 224.0.0.0 and between 239.255.255.255. So this is the range for multicast address. So if you're creating a multicast cluster address, then you can specify a value between these. Now this is about unicast. So unicast is different than multicast, and for managing this cluster messaging and communication, and it is simplified comparing to multicast addressing because it does not require your cross network configuration. Okay, there is one more thing I forgot to tell you for multicast. So multicast, it is also prone to network multicast addressing conflict. So let's say I have used the IP and port combination for multicast. It may happen that on the other environment where I'm trying to send message, or there is another domain which is there, so it can, that address can conflict. So we can have the same address IP and port which is already present, so that conflict can happen. That is not present in unicast because unicast, it uses its own network channels, or it uses its own addressing, so that is not possible in unicast. So it is not prone to this network conflict. Okay. Okay, although it is written, so additionally it reduces potential network errors that can occur from multicast address conflicts. So that is not possible in unicast, so there won't be any address conflict in a case of unicast. So when we should use unicast? So below are the few instances where you should go for unicast. So all members of a cluster must use the same message type. So whenever a cluster uses the same message type, you should go for unicast. So unicast, when you are using unicast, you cannot mix it between multicast and unicast. So it should be just one mode. So if you have two across, you have created domains, you have created, let's say, admin server and manage server on physical machine 1 and physical machine 2, you should be using a same messaging mode for both of them. Now use multicast if need to support previous version of Weblogic server with your cluster. Okay. Now in case you are using previous versions, then you can go for multicast, although it may come up with some issues, but unicast definitely cannot be used. So in such cases, multicast should be used. Individual cluster members cannot override the cluster messaging type. So these cluster members, they cannot override the cluster messaging service. Then you should use unicast. The entire cluster must be shut down and restarted to message modes. And JMS topics configured for multicasting can access Weblogic cluster configured for unicast because the JMS topic publishes messages. Okay, so this is for JMS when you make a cluster for JMS topics. So these JMS topics configured for multicast can access Weblogic server configured for unicast. So if you configure JMS topics on multicast, they can still access your unicast addressing which you have clustered managed servers on unicast mode. Because what JMS topic does is it publishes message on its own multicast address. So the multicast address, the IP port combination which you have put for multicast, JMS topic can publish it there, which is independent of cluster address. So there won't be any conflict of ports and it can still use it. Although we don't do this mix and match, and organization hardly goes for it. They go for unicast primarily, that is the Oracle recommendation as well. Otherwise, if it requires, they'll go for one multicast and that IP and port they'll be using. Okay, so multicast, it's an address, and multicast port is used for listening to message. Unicast, it is a network channel used for communication between servers. If no network channel is specified, a default network channel is used. So you can create a network channel for unicast messaging mode. If not, it creates its own. So we'll test this both. We'll create a unicast without specifying a network channel, and we will also do it with specifying the network channel. So we'll see that when network channel is not created, it will start listening on its default network channel. Okay, so in multicast, each server communicates with every member of server in the cluster, which means heartbeats are sent to every server. So like I said, in multicast, it broadcasts messages. So it will send heartbeats to each and every server. So one through this one managed server IP, one IP and port combination, it will distribute, it will broadcast these messages to everyone, but it will not take a confirmation. But in unicast, what happens is, the member of servers in the cluster, group leaders are chosen, and only those group leaders communicate with the servers among the group. And these leaders notify each other about the availability of all of the servers. So now there is a delay. What happens is multicast is messages are being broadcast to each of the managed servers, and then it becomes the responsibility of managed servers then that they have to send back, or they have to get the details about other managed servers across. So when these messages are broadcast, these heartbeats, each managed server should communicate to each other. So in case a communication is being broken anywhere, then those messages will not be available to cluster, so other members in the cluster. So that's a drawback of multicast. But in unicast, what happens when you create a cluster, there is a group leader being decided across, so it forms a group. First thing is it forms a group. I'll show you when we'll create a cluster, so how this group is being shown. So once that group is created, there will be a group leader which will get the message, and then it will be passed across. So all these managed servers groups, they will get the details, faster. So unicast communication is faster as well, considering to multicast, and heartbeats will not be lost in unicast communication. Now there is an example given. Suppose there are 6 servers in the cluster. So there is a cluster where you have 6 servers. 2 groups are made and 2 are group leaders. So 2 groups are made and there are 2 group leaders. Other 2 servers of the group will notify their leader. So let's say out of 6 servers, there are 2 groups created and there are 2 group leaders. So group 1 and group 2. In group 1 there are 3 members, in group 2 there are 3 members. So group 1 have a leader and group 2 also has a leader. Now the 2 other servers, managed servers, which is part of the same group, they will notify their status to group leaders, and then group leaders in turn can notify it to the cluster. So that way everyone gets the communications quite faster in case of unicast. So they'll notify their leader that they are alive, and group leader will send this information to the leader of other group. So that's how they will communicate across groups. So they'll come to know that managed servers is still up and running. In case any one of the managed server goes down, sorry, and group leader comes to know that this managed server is down, it will send that to other group leaders saying that this managed server is down, and going forward the request will not come to that managed servers, because all of the managed servers within that cluster will be aware that this particular managed server is down and requests should not be sent to anymore. Now frequency of communication in unicast mode is similar to frequency of sending messages to multicast port. Okay, so frequency is same, but the mechanism of sending messages across is different. Okay, so how does this looks like? So this is in terms of config.xml. So how it will be specified? So let's say this is your design where you have managed server 1 and managed server 2, and then you have managed server 3, managed server 4, managed server 5 and managed server 6 as well, and this is your administration server. So in config.xml, how is it will be specified? So you'll have a detail about your admin server in your config.xml, which is your configuration file consisting details about your whole of the domain. So your whole domain resources, admin server, managed server, their ports, listener, everything is specified in this file. So this file is like backbone of your WebLogic infra. So if these files get corrupted to any extent or any issues with this file, your WebLogic infrastructure will not come back. So your admin server, you have created 6 managed servers. Now we have created a cluster A which consists of managed server 3 and managed server 4. You have created another cluster B consisting of managed server 5, managed server 6. And then managed server 1 and managed server 2 are non-clustered. So they are kept independent. Now what happens when you deploy a application, you can deploy it on cluster A and cluster B, or you can deploy it on both if required. And depending upon whether you want it to deploy on these or not, you can keep it independent. Okay, this is also possible during deployment. Then you can deploy even as a part of a cluster. That is also possible. So in your config.xml, when you will have this configuration, at that time this information will be kept as non-clustered. Manage server 1 will be kept as non-clustered. Manage server 2 will be kept as non-clustered. Cluster A will have information about manage server 3 and manage server 4, and cluster B will have information about manage server 5 and manage server 6. So probably we will not be able to create maybe 2 clusters. Let's see if our environment supports, we will see that. Otherwise, we'll create at least 1 cluster and 1 non-cluster, and we'll see how this config.xml looks. Okay, so load balancing in cluster. So we have load balancing for servlets and JSPs. Load balancing can be done for EJBs and RMI objects, and load balancing can also be done for JMS, which is Java Messaging Service. Now, for servlets and JSP, we can do load balancing with a proxy plugin. So that means we can use a web server which typically uses your HTTP cluster servlet. So if we use a web server which can proxy those requests to your managed servers. So with web server and associated proxy plugins, so Weblogic server with HTTP cluster servlet, or Netscape Enterprise. This is in case of your if you're using a Mac machine. So if you're using Apple Mac, then this will be your default browser. So that proxy plugin can be used. Otherwise Apache with Apache server proxy plugin, or otherwise Microsoft IIS server, which can use its own proxy plugin, and using that it can load balance your servlets and JSP. So mainly using a web server and proxying that request. So when we'll do let's say when we'll create this HTTP server or the OHS, and when we'll do a proxy through that, when we'll do integration between Weblogic and our HTTP server, that will load balance your servlets and JSPs. Okay, also it can be done so that JSP servlets can be done through external load balancer. So something like F5, which is a hardware load balancer. And although this is a part of it, but it has many other algorithms. So you can do it based on passive cookie persistence. You can do it based on active cookie persistence. You can do it SSL persistence. So using an external load balancer, this can be done. So external load balancer is always recommended for a high traffic load, because WebLogic server comes with a definite set of algorithms. It doesn't have quite many. It has like 5 or 6. This is like WebLogic weight-based algorithm or weight-based affinity. So it is like round robin and few others. So in such cases, we should go for external load balancer, so that mainly cookie and SSL persistence can be taken care by external load balancer. And if we'll talk about session cookie, this is how it looks. So there will be a session ID, and then primary server ID and secondary server ID. So whenever a cookie is being generated, it is generated in this format. So session ID will be there. So there will be a session ID generated as a part of that request, which will append your primary server ID as well as secondary server ID. So in case a session ID is being running and your primary server, it is processing it, just in case in unfortunate instance anything happens to the server, immediately it can be processed through secondary server ID, and that makes it load balanced. Now session ID is a randomly generated identifier of HTTP session. The length of value is configured by ID length parameter in the session descriptor element in weblogic.xml file for an application. By default, the session ID length is 52 bytes. So the session ID, which is here, the first part. So when your request comes in, it comes in session ID, primary server ID, and secondary server ID. So this session ID, it will be of 52 bytes, and this will be mentioned, it will be generated through this identifier which is mentioned in your weblogic.xml, and ID length parameter which is defined inside this session descriptor. So whatever you have defined that configuration through weblogic.xml, it will create a session ID, and that session ID appending with primary server and secondary server will become part of your cookie. So this is how your session cookie will look. And your primary server ID and secondary server ID will be of 10 character identifiers of your primary and secondary hosts. Okay, so for context for a cluster, so this is for your EJBs and RMI objects. So if you have any EJB enterprise Java events or RMI objects, how they'll be cluster. So let's say there will be a stub. There is a stub A which will check for a cluster address. So let's say it found the address that there is MS1. So it will do a lookup first for the objects. Let's say it is looking for A. Okay, and it is looking for A. So for it first looks up for this and then calls on it. Similarly, if it looks up for B on MS2, then it makes a lookup for B, and if it finds it, which is already connected, so this is already connected to this cluster address. So considering if it is looking for A, it will go to MS1, although it has both, and then if it looks for B, it can go to MS2 and takes it from there. So this is like round affinity, where it can go for any of the servers. It can go for MS1 or MS2, or it is also possible then it can also go to MS1 both times. So it's round robin, but what happens in round robin, it just gives chance to each of the managed servers. So let's say it has make a call for A and it goes to MS1 and picked it up. Next time it calls B, another object, so it can go to MS2. Third time if it calls again another object C, so it may come to MS3. So that's a typical in terms of EJB objects if it wants to make a call. This example is for round robin affinity. Okay, cluster architecture. This is a typical, the basic cluster architecture looks like. So when it says untrusted, this is nothing but your web. So any request coming through web to your environment, so that will be tackled by a firewall first. So it is recommended that you place a firewall so that any users from a web directly or from their client at home cannot hack your environment. So when a request comes from outside, it first passes through a firewall, which is a set of rules which blocks unauthenticated requests or untrusted requests that can be blocked here. From this firewall onwards, it comes to a load balancer, which can be any of your load balancer, maybe FI, or if you are using a software load balancer, it can be your like for example, your Oracle has one OTD, so which is software based. So OTD can be also be used as a load balancer, which is software load balancer. Or otherwise, if your organization goes for a hardware load balancer, it's called Cisco FI, big FI. So using that load balancer, a request can be sent to these managed servers, which internally will have their own set of communication mechanism. So in this case, we will have HTTP, JSP, servlets, EJBs, JDBC. So these are the objects across. So consider this is one of the managed servers, this is another managed server, this is another managed server. So 3 managed servers, which in turn will be connected to database. So depending upon what kind of request I'm asking for, if it is the HTTP session is what I'm asking for, it will go to HTTP, connect to HTTP session, and it will connect to the required JSP or servlet is what I'm requesting, which in turn, let's say a JSP is being requested. So HTTP session in turn has connected to a JSP page, which called for a servlet or which called for a EJB object, which in turn this EJB will connect to JDBC, which JDBC in turn will connect to your database, get the required details, put it back into managed servers, and through load balancer it will finally pass on to your web client. So this is how a typical managed server look, where you have a firewall, a load balancer, the managed servers, objects within managed servers, and then a database connected to it. Okay, so this is about a typical clustering. Okay, let me see. I think I forgot to start my servers today. Let me start my machine. So what we have seen today is horizontal and vertical clustering. unicast and multicast addressing, network channel for unicast and default unicast addressing. One second, let me connect my charger. Okay, so this is my address. Let me go and see. So I'm connecting to my server 192.168.0.103. Okay, so it's connected. Let's go to console. It says firewall is already running, so let me see. Let's check if Firefox is running. Yes, it's running, and instead it says 2 instance. Okay, but I have already got it, so I'll not kill it for now. Okay, not responding. Let me run it again. Okay. So I'm gonna kill this one. The reason being it's already running somewhere in the background. And then I'll do it again. So let's go to our console. Okay, so this is my environment where I think cluster was already created. Let me delete it first. Okay, but I think I cannot delete it because servers may be running. So let's stop the servers first. So instead of shutting down the servers, what I've done is I've just removed it from the cluster so that I can. Okay, it's not taking it. Let me do this then. So I'll go to control, shut down these two. Okay, it must be shutting down. Okay, shutdown is completed. Let me do activate changes. Okay, so it's being done. Let's see. Okay, so cluster, there is nothing. Let's check for the servers. Nothing. So I can remove this now. Okay, so my cluster is being removed. And now remember this cluster, we can add it through console, and we can also do it at the time of configuration. So if we have environments beforehand, if we have details about the whole architecture which is required to be set for our organization, so they have already documented it and architecture is in place, so we can create it during our configuration. When we run the configuration wizard, at that time that cluster can be created and servers can be assigned to it. If not, we can create cluster after admin server. Once admin server is created, we are in admin console, we can create the cluster. So to create the cluster, I'll go to my environments, go to clusters. Now here I have options for new, clone, delete. I'll click on lock and edit. I'll go for a new, create a cluster. I'll tell you about dynamic cluster also later. So there will be something called dynamic server and dynamic cluster. So that I'll explain you. So let's say I'm naming it fmw underscore cl1. So that's the cluster name I'm assigning. And you see default is unicast. If I want to make it multicast, let's go with multicast first. So I'm making it multicast and it has already taken an address. Okay, and I can keep the port same or I can also change the port. So 7001, but 7001 is usually we use for admin server. So if I want to change it, I can also change it. I can make it 8. But it doesn't matter. The reason being 7001, which I'm using for admin server, the IP will be different. So IP will be my server IP. So 7001 will be listening on, let's say, this. But if in case I just want to change it, I have this IP at, this is my multicast address. And then this can be done. So I'm creating it on multicast. Let's just see how to do it. So this cluster is being created on multicast and database migration is on database. Default algorithm, it has taken round robin. Now I'll assign servers to it. Let me first activate changes. Okay, so this is created. And let me add servers to it. So if I want to add servers, I can go here, first click on lock and edit, add, and I will add these servers. MS1 I am adding. So let's see, it is being added. Yes, it is being added. Let me add another one. So MS2. So I've also added MS2. So these two servers are being added to this cluster. Now let me do activate changes. So I've done activate changes and let's see. Sorry. Clusters. Now I can see that this cluster is being created, which clustering messaging mode is multicast, migration basis database, round robin, these are same. And now I can see the servers. So there is a MS1 and MS2. And you see that cluster address and cluster broadcast channel is run. Cluster address I can specify in two ways. Even if I don't do, system takes it automatically. But if I want to do it, I can also mention server IP and port. So let's say in my case it is 192.168.0.103 colon 7100. And then sorry, it's not 7100, I think 7103. So that is nothing but your managed server 1 and managed server 2. So you can specify using this. And then if I'll check for the cluster, summary of cluster, now it will show me cluster address here. So this is one way. I can also do this. I can go here and can assign it a name as well. So I can mention it fmw underscore cluster. This also can be done. So I can save it as that. And then my cluster address will be a cluster. But when I assign it a name, then I have to make sure that, or a host name, then this should be there in my etc host as well. So then I'll have to change into my etc host. I'll have to create an entry, and I'll have to assign this for all my managed servers or all my hosts. So this has to be done. So this I'll tell you later when we'll go for the next session. For now, I'll keep it empty. The reason being, I have to show you the default one as well. Now I can mention these two, and I can also keep it default. So if I keep it default, system will automatically generate a cluster addressing. So that will be visible when we'll start our managed servers. So this we will keep tomorrow's session for clusters, unicast, multicast, and we will also try to see this vertical clustering. And I'll try to create one managed server, one more managed servers depending upon my capacity. Let me see how much I have. So it says 25 gigs. Most probably I should be able to do it. So let me see. I'll create it. So we'll do this unicast, multicast messaging tomorrow, and also on we'll see on vertical clustering and what all clusters mechanism which we have. So that will be doing it tomorrow. So we'll wrap up this class here today. Any questions from this, Rakesh, for today? Can you hear me, Rakesh?